this third example, we have sine squared x minus sine x plus 1 is equal to cosine squared x for all real values of x. Again, it says all real values of x. So your answer should be in radians, and it should have some type of multiplier of pi, where n is an element of the integers. So again, we're going to look in this problem, and we're going to find out if there's anything to the power of 1, because that's probably where we need to focus. And if you see sine x here, sine x is to the power of 1. So I'm probably going to replace this cosine squared x with its Pythagorean identity. And so sine squared x minus sine x plus 1, and then is equal to, instead of cosine squared x, I'm going to put 1 minus sine squared x. So that's the Pythagorean theorem identity equivalent to cosine squared x. Then I'll move everything to the left of the equals and set it equal to 0. So that means that I'm going to subtract the 1 and I'm going to add the sine squared x. So again, we can see these 1s are probably going to cancel and the sine squared x is going to double. So we end up with 2 sine squared x minus sine x. Now remember, that is the same as saying like 2x squared minus x equals 0. So if I say something like 2x squared minus x equals 0, then that should factor to become x, and then 2x minus 1 equals 0. So pretty much that's what's going to happen. So I'm going to take out a sine x, and then 2 sine x minus 1 will equal 0. Now, in this situation, x would equal 0, and then x would equal 1/2. So that's probably what's going to happen over here. So sine x is going to end up equal to 0, and sine x will equal 1/2. So then you have to ask yourself, when is sine x equal to 0? And when is sine x equal to 1/2? Remember, they want real value. So this is going to happen at 0 and 180. And this is going to happen at 30 and 150. So we're not done yet because we're still only talking in degrees, but we have them all listed. So 0 and 180, 30 and 150, plus or minus 360n. Now it's probably a good idea to go ahead and transfer that into radians because they wanted all real values. So since they wanted all real values, I could simply say 0, then pi over 6 replaces 30, 5 pi over 6 replaces 150, and pi replaces 180, plus 2 pi n, where, I'm sorry, right down here, where n is an element of the integer. So you can use your degrees to write your answers and convert them to radians, and that is fine. Okay, in this fourth example, we have sine x plus sine x times cosine x equals 0. So you can see here that everything's to the power of 1. So we really don't have the ability to replace a trig function with another trig function, but we do have a common factor of sine x. Now, if you recall when I showed you how to simplify trigonometric identities, I also showed you a way to write them algebraically. So sine x is y, and cosine x is x. So basically you have a scenario where y plus yx is equal to 0. And so just like I could factor out a sine x, I can factor out a y. So we could say sine x times 1 plus cosine x equals 0. We could also say y times 1 plus x is equal to 0. Now I can set both of those values equal to 0 and solve for them separately, so there was no reason to put it in the same trig function because they were linear factors and they were easily solved for by splitting them with the greatest common factor. Now, when is sine equal to 0 and when is cosine equal to -1? Now here they only want the principal value, so that means you just give them the answer the calculator gives you. So if you do second sine 0 and second cosine -1, your calculator is going to give you the values of 0 and 180 respectively. Now over here, we are saying that y is equal to 0 and that 1 plus x is equal to 0, therefore x is equal to a negative 1. And then at this point, I simply replaced y with sine x and x with cosine x. And then I can say that sine x is equal to 0, cosine x is equal to negative 1. And we know that that occurs for sine at 0 degrees or 0 radians. And for cosine, then it works at 180 degrees or it works for pi radians. In this example, sine 2x is equal to a negative sine x. So you can see we have a double angle formula. And we also have another trig function. So we're probably going to have to rewrite the double angle formula with its equivalent value. So that's probably what's going to need to be replaced. So I'm going to say 2 sine x cosine x is equal to a negative sine x. And that would be the equivalent algebraically of saying 2yx is equal to a negative y. Now, I can move the sine x to the left, just like I can move the y to the left. I can factor out a y, just like I can factor out a sine x. And I end up with sine x times 2 cosine x plus 1 equals 0, just like I would end up with y is and times 2x plus 1 is equal to 0. And in that situation, y would equal 0 and x would equal negative 1/2. Respectively, that means that sine x would equal 0 and cosine x was equal negative 1/2. Now remember, they wanted principal values for both of these, so that's the one the calculator would give you. So the calculator would give you 0 for the sine value and 120 for the cosine value. Now you could have also said 0 and 2 pi over 3, and you could have been in radians, and that would have been fine. Now for this last example, I have sine squared x plus cosine of the double angle x minus cosine x is equal to 0. So I'm probably going to want to rewrite cosine 2x. Now there's 3 of them, so you sort of have a choice. And there, you could actually also rewrite the sine squared x if you want to. So there's a bunch of different things you can do here, but I think I'm going to rewrite cosine squared x. I'm going to rewrite cosine of 2x using cosine squared x minus sine squared x. I think that one will be handy because there is a sine squared x in the problem, and they will cancel out. So I'm going to go ahead and write down sine squared x, and then I'm going to replace cosine 2x with its identity cosine squared x minus sine squared x, and then minus the cosine x. And I think we can see here, this is convenient because the sine squareds will cancel. So since the sine squared x's cancel, we're left with cosine squared x minus cosine x, which is equal to 0. And that's the same thing as saying like x squared minus x equals 0. So we're going to factor out a cosine just like we would factor out an x. And then we will set them both equal to 0 and we will solve. Now I think it wanted our answers from 0 to 360, so that means they want the unit circle value. So the cosine's equal to 0 at 90 and 270, a cosine's equal to 1 at 0. So those are our answers. And since they wanted degrees, but in a problem where they wanted radians, you would have said pi over 2, 3 pi over 2, and 0 as well. So just keep that in mind. So this is the end of the notes. I did make this into 2 parts because I didn't want the video files to be too big, but this second part is less than 10 minutes. So that's good. So I think it was roughly about a 40-minute lesson. So this will be the last lesson for the week. And next week we will start logarithms. We'll finish whatever homework and review sheets for this week. And that'll take us through Friday. So I will post this in an assignment in Google Classroom.